right, we're on part 3 of our final review. Sorry guys, it's going to be 4 parts. It's about 40 questions, so I'm doing like 10 a piece or 11 a piece. So 23 says translate into a variable expression the total of twice V and 8. It says the total. All right, so we're talking about total, so we're talking about sum. We're adding. What are we adding? What are we adding? So it means going to be 2 terms, right? What are we adding? We're adding twice V, right? And so wherever your and is where you put your operation. Twice V. What about V? 2V and 8. That's 23 for you. All right. Total of twice V and 8. All right. 24 is saying a rectangle has length of 6.3 inches and a width of 4.9 inches. Find the perimeter of the rectangle. So if we set up our rectangle, we know that opposite sides are equal. So length is 6.3 and width is 4.9. Perimeter means the sum of all sides. So all I'll be doing is adding 6.3 plus 6.3 plus 4.9 plus 4.9. Or you can say twice 6.3 plus twice 4.9. Whatever floats your boat. So what is that? 12.6 plus what's that? 9.8. And what is that in person? Good old 22.4. Alrighty, next question. Alright guys, so here graph the following ordered pairs. Remember I told you this is the most you'll see for graphing at this stage. They just want you to graph these pairs 1 and 3, 0, 4, -4, -4, and 3 and 1. All right, so here we have our graph. We have our y-axis and x-axis. Positive values are upward, negative values are downward for y. Negative x values are to the left and positive x values are to the right. All right. So we know that our coordinates are set up as all x and y's, x and y's, x, y's, x and y's. So here we go. The first system says when x is +1, y is +3. So we start from the origin to x, we go right, and then from x we go up 3 places. 1, 2, 3. Should be somewhere around here. Our next value says that when x is 0, so we stay at the origin, y is +4, so it's somewhere here. Our next system said when x is -4, so from 0 to 4 places left, y is -4, so it's somewhere down here. And then it's saying when x is 3, y is 1, so 3 and 1. And that's all there is to graphing until you see the next level of math where they get more in depth. So that's number 25. All right, one of the last things we looked at was that a home builder obtained a pre-construction loan of $590,000 for 4 months in an annual interest rate, annual meaning yearly, of 9.6%. What is the simple interest rate due on the loan? Now remember, it's 4 months. So remember, simple interest is I equal PRT. Over the several years I've been teaching this course, they always bring a simple interest problem. They keep it very simple. So the principal we know is the big number here, 590,000. The rate is always represented as percent, and it was saying annual simple interest, but they're asking over the course of 4 months. So what does that? That's a fraction of a year. So that fraction of a year is represented of 4 over 12 because there's 12 months in a year. Reduce that fraction, so it's really 1/3 of a year. And then you just plug in I equal PRT. So this is I. What's the interest? It's the principal times 9.6 over 100. And there's a reason why I put that 100 because it gives me the opportunity to cancel 2 zeros times 1/3, right? PRT. So I'm going to cancel my 2 zeros. So now I'm left with a nice simple number, not to be misconstrued with simple interest, of 5,900 times 9.6 times 1, which we don't really have to put back. And all of this is divided by 3. And whatever this works out to is what your simple interest will be. And you can simply calculate that. And let's see what that looks like in real life. Great. So the numerator 5,900 times 9.6 will give us 56,640 divided by 3, and that will give us 18,880. And that's all there is to simple interest. Say it's beautiful. It's beautiful. All right, so the next question is taking us down memory lane. The next two questions, finding the LCM and finding GCF. We'll start with the LCM first of 2, 4, and 13. And of course, 2 is already prime. 4 is 2 factors of 2, and 13 is already prime. Remember, when we're looking for the LCM, we take the unique factors, and we take the unique factors that occur the highest amount in any single number. So this is actually 2 squared. So it's actually 4 times 13, which I believe is 52. So the GCF now is the greatest common factor, which is 8, between 8 and 15. So I am going to prime factor my given numbers, right? And what I'm going to do in this case, you see how for LCM I took unique factors and take the highest of that they occurred any one time? No, actually for my GCF, I have to see which factors of the two numbers, what do they have in common? Which factor they have in common? And if I look at 8 and I look at 15, they have nothing in common. And whenever you can find common factors between your GCF, the common factor is always 1. So in this case, your GCF would be 1. So that's taking us back down memory lane. Of course, so you know what they're leading us up to, into fraction questions. So now they're starting us off nicely here, asking us which of the fraction, put in an inequality symbol between the fraction, which one is greater, which one is lesser. Remember, Pac-Man always eats the bigger one. So let's see how do we do that? Of course, in order for us to know which fraction is greater, they have to have the same divisor. It has to be from the same whole. So here we'd have to find an LCM, which I hope you can obviously see is 42. So let's see what our equivalent fractions are with denominator 42. So 7 was changed by a factor of 6 to get 42. Yeah. So times the numerator, we get 24. And 6 was changed by a factor of 7 to get 42. So of course we times that by the numerator, which is 35. So it looks like the fraction 5 over 6 is greater. Pac-Man eats the bigger number. All right, so they're coming down now to one of my favorite things to do in fractions is to multiply them. The only thing that should really stumble you, because it's an issue that most students have, even no matter how high the level get, it's an issue, signs. So try to get rid of that out of the way. Try to have in mind what the sign of your answer will be. And here we have even number of negatives, or 2 negatives. Excuse me. Which will yield a positive. So you know your answer is going to be positive. And what I like to do is to prime factor all of my numbers. So notice I didn't rewrite the negative because I already conclude my answer is going to be positive. Then I'm going to look to see if there are any common factors in the numerator that I can cancel out from the denominator. And it looks here, I have 4 factors of 2. Don't be tempted. We don't cancel side by side. We do cancel vertically, not horizontally. And it looks like the only factor that this whole multiplication has in common is 3. So I'm left with 4 factors of 2, which is 16 over 35. And that's my final answer for number 30. Next. So 31 is asking me to find the product of negative 4 2/5 and positive 2 1/3. And remember, product means to multiply. So it's asking me to multiply 2 mixed numbers, which of course I'm going to convert into improper fractions first. And I can conclude first that the sign of my product will be negative because I have a negative factor times a positive. Remember, when we're multiplying on like signs, we yield a negative. So let's first start by converting into improper fractions. So here we have negative 22 over 5 times 7 over 3. And just to be on the safe side, I can convert into prime factorize each term, each constant or each factor to see if they have anything in common. As you can see, they don't. It just looks like it has one big hefty set. So I'm not going to do 2 times 11 times 7. I'm just going to go, 22 times 7. 7 times 2 is 14. 7 times 2 is 14 and 1 is 15. I hope I did the correct thing. And this is over 15. So this is negative 154 over 15. And of course, because initially they give it to you as a mixed number, chances are they might want it back as a mixed number if, because I'm not grading it anymore. It's WebAssign. Sometimes WebAssign give you the correct a check for improper fractions or an X, or if not. So let's see, just in case. Like I said, I'm manually checking your work so you don't have to panic. So this is actually 15. 1 factor of 15 is in 15. There are no factors of 15 in 4. So my remainder is actually 4. So so my final answer as a mixed number would be 10 and 4 over 15. If that's what they're looking for. Either way, I'll take either answer. Let's see what they're asking for number 32. So they're actually asking for the divide or the quotient, right? If put other words, of 2 negative factors that are fractions that are factors. All right. So obviously my answer is going to be positive, and the left fraction is my dividend fraction, and the right fraction is my divisor fraction. And based on the rule of division of fraction, it's always the dividend, and I'm just going to make that positive because I conclude that my answer will be positive, times the divisor or the reciprocal, right? Invert that, right? Invert. Let me just put an arrow of the divisor. Now I'm going to prime factorize to see if there's anything in common. Just playing it safe. And it looks like the only thing they have in common here is 7. And I'm left with 3 factors of 2 to give me 8 and 2 factors of 3 to give me 9. This was a beautiful problem. Next. So it was all easy peasy for multiplying and dividing until we had to add and subtract, which I know is the kryptonite of some of you for finding the LCM. Now, hopefully these are one of these numbers which are obviously they don't have any common prime, so they're unique in their own way. So this is actually whenever your denominators are unique and they don't share anything in common, usually their product is the LCM. So the LCM here is 8 times 9, 72. So let's see what's, so now I'm going to convert these into equivalent fractions, right? So 72 is my new denominator, and let's see what will make it, what 5/8 equivalent to what fraction over 72. So we ask ourselves, what factor times 8 will give me 72? That's the same factor I have to multiply the numerator by, and that's 9. So 9 times 5 is 45. And we asked the same question. This was 8, so this was 64. So here we have positive 45 and negative 54. So obviously because they're terms, we're going to have to find the difference because they have opposite sign. And then keep the sign of the greater magnitude. And let's see what that is. So that looks like 19, negative 19 over 72. And 19 is a prime number, 72 is composite, and I don't think they have a common factor of 19. So this is my final answer for number 33. Let's move on to number 34, which is actually asking you to find 1 and 5/12 plus 4 and 5/8. So they're asking you to add 2 mixed numbers. Now, there are a couple of ways you can do this, actually 2 ways, where you can actually add the whole numbers together, 1 plus 4, and then add the fraction part separately. Because what a mixed number is actually a whole number plus a fraction. That's what mixed numbers are, right? So here I have 5. And here I would have to find the LCM, which if I break them down into primes, I'll see that my unique factors are 2 and 3. And the most times 2 occur was 2 to the 3rd power right here. 2 to the second power here, 2 to the third power. I take the biggest one, so that's 8 times 3, which is 24. So my LCM is 24. And of course, if you have hindsight that your LCM is 24, good for you, not a problem, right? So let's work this out. This is 24 as my new LCM. The missing factor here is 2, and the missing factor here is 3. So that is actually 10 plus 15, right? Which is actually 25 over 24, right? And so you see what's happening here? Now I have to convert this into a mix. This is 1 and 25 and 1 over 24, right? So this is actually 1 plus 1 over 24. So 5 plus 1 would give me 6. So 6 and 1 over 24, right? So one of the reasons why I don't like showing this method is because of what happens here, right? Sometimes if you get a proper fraction where the numerator is smaller than the denominator, you can go right away into saying 5 and, you know, let's say 2 over 24, 3 over 24, which you got to reduce if it was those numbers. However, when you get an improper fraction, you got to convert that into a mix and then add it towards the number. So it gets a little hairy there. So let's try the other way where I'm actually going to convert these into improper fractions. All right, so yeah, so the thing about converting mix into improper is that the numbers can get pretty big and ugly also. So sometimes you just can't run from how complicated something might look, but not actually is. So we see here that we added the whole numbers and work out the fractional part. And then because it yielded a mix, we had to convert and then continue adding whole numbers, right? Here, this looks like a simple process, but we're going to get some pretty big numbers. So here we have 17 over 12, right? Because 1 times 12 is 12 plus 5 is 17 over 12. And here 4 times 8 is 32 plus 5 is 37 over 8, which actually is, if we understood that the LCM is 24, so the missing factor here is 2, so that'll yield 34, and the missing factor here is 3, which will yield 111. And when we combine these two, we will get 145 over 24. And then when we actually perform a long division on this, you'll actually get 6 and 1 with 1 remainder 1, because 6 times 24 is 144, and remainder 1 over 24. All right, so you see the difference in terms of steps here, right? Like just from here to here, but there's behind the scenes scrap work in terms of figuring out, what the quotient of 145 and 24 is. So some people might prefer this method, or some people might prefer that method. However, I advise that do not try the same for subtraction unless you're really solid in understanding your game here. But if you have subtraction of mixed numbers, I suggest convert it into improper and then convert it back into mix if necessary. All right. All right. So this is ending of part 3. We're going on to part 4 next.